Okay, this is a video for section 8.8, and what we're doing is factoring perfect squares. What does that mean? The difference of squares is when you have a subtraction sign, so that's one of the things you're looking for. And then squares is the other thing you're looking for, so like m squared, y squared, x squared. The other thing is perfect squares, which means this. We know that 2 times 2 is 4. 1 times 1 is
1.
3 times 3 is 9. 4 times 4, 16. Instead of writing it like this, I'm also going to write it like this. 5 squared, because there's 5 times 5, that makes 2 of them, is 25. This is why they call them squares, perfect squares, because it is 2 of them multiplied together, and we write it as 5 squared. 6 squared is 36. 7 squared is 49. 8 squared is 64. And you're like, I already know these. I don't need to write them down. It just helps you identify them faster, especially if they're not perfect squares, because you don't see one of these. 9 squared then is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. Miss Hernandez, do we really need all of these? The answer is yes. 13 squared is 169, I think. Let's take a look.
169, you're right.
And then I also need 14 squared, if you'll do that for me, because I don't remember.
196.
196. Thank you. So you do need all of those. Make sure you keep those in mind. Those are called perfect squares. It is also a good thing to recognize those numbers and that pattern. All right, so let's take a look at the first one. It says factor the polynomial if possible, and if the polynomial cannot be factored, then write prime. So look at this. Is this a square? 4 squared is 16, so yes. Is this a square? Yes. 11 squared is 121. That means that this is a difference of perfect squares. We can do this the exact same way we've been doing this. Making a box. We write the 16m squared here and the negative 121 here. But this one is actually a little bit easier because we're actually going to work outside of the box already. Because I know this has to be 4m and 4m. Because that's the rule for perfect squares. Since this is a negative 121, one of these factors will be a negative 11, and the other one will be a positive 11. So if you don't like this new method, we can still do the same old method. But watch this. 11 times a positive 4m is a negative 44m. A positive 11 with a positive 4m is a positive 44m. And they end up canceling out. There is no middle term. There's no 0m that needs to be written. So we know that these are the correct factors. Making 4m minus 11 and 4m plus 11 the factors of these two sections. Please keep an eye out. You have to be careful. We want to see if there's a plus sign or a minus sign. We have to see if both of these two terms are the same. But I want to go down to problem number 10. These two numbers are not numbers on our list. 8 is not a perfect square. 50 is not a perfect square. But we can factor out a 2. This doesn't happen very much in this homework, but I want you to be aware of that. So what does that mean? This is 4n squared, and this is a negative 25. Now is it a difference of perfect squares? Mm-hmm. Yes. 2 squared is 4, 5 squared is 25, and there's a minus sign between them. So I'm going to ignore this 2 for a few minutes and just make my box with the 4n squared and the minus 25. This section's a little bit easier when we have that specific situation. I know that this has to be 2n and this has to be 2n. Negative 5 and a positive 5. Give me a negative 10n and a positive 10n, which cancel out. That's what I want. And it works every single time, so this section's a little bit easier. And that's supposed to be a 0n, by the way, not an on. Making my 2 factors, 2n plus 5 and 2n minus 5. It's still equal to 0, but can I ignore that 2 now? No, we still have to put it all the way at the front. Luckily, when you have that extra factor, you can divide by 2 already to cancel that one out, making 2n plus 5 and 2n minus 5 the only real factors we need. That 2 is sort of like a scale factor. It doesn't really actually change the value. So now we have 2n plus 5 is equal to 0. Solve for n. Minus 5 to both sides. 2n is equal to negative 5. And then divided by 2. N is equal to negative 5 halves. Please leave your answer as a fraction. And then I'm going to write, or we could have had the 2n minus 5 is equal to 0 because of this factor right here. If you know that you're not going to have enough space on this piece of paper, please feel free to write it on a separate sheet of paper. 2n, and then we're going to divide by 2. N is equal to 5 halves. So we're doing the same thing we've been doing. Please don't be scared of fractions. It is still a perfect square. The perfect square for this one would be the 1/3 because 1/3 times 1/3 makes 1/9. And then when you have equations that don't equal 0, make sure that you move them and factor out anything you need to have that perfect square.